Welcome, dear students. In today's session, we will be talking about demystifying indeterminate forms, and you are on my classroom. So, what are these indeterminate forms about, and what are the concepts and misconceptions revolving around them? Let us look into it. What are the indeterminate forms? All your textbooks say there are 7 indeterminate forms, and what are they? 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, and then 0 power 0, infinity power 0, and 1 power infinity. These are the 7 indeterminate forms given in all the textbooks. Many students have a doubt why these are indeterminate forms, and also are these the only indeterminate forms, and are they not the indeterminate forms? What are the indeterminate forms? Presuming that they are indeterminate forms given here, 1 by 0, is it not indeterminate? 1 by infinity, is it not indeterminate? Infinity into infinity, how about that? 1 power 0, is it not indeterminate? Infinity power infinity, is it not indeterminate? So, to answer these questions, first and the foremost, you need to know what an indeterminate form is. Let us look into it. What are indeterminate forms? Let's say you have a limit extending to a f of x by g of x. This is called an indeterminate form 0 by 0 if as x approaches to a, as x tends to a, f of x tends to 0, that is the numerator is tending to 0, and g of x is tending to 0. Then this is called an indeterminate form 0 by 0. Is that clear? Limit extending to a, f of x by g of x is said to be of an indeterminate form 0 by 0 if as x approaches to a, f of x, the numerator of the limit is approaching to 0, and g of x, the denominator of the limit is approaching to 0. If both numerator and denominator are approaching to 0, then it is called an indeterminate form 0 by 0. Let us see if you have understood this. I'll give you some limits and you have to tell me whether they are indeterminate forms. Limit extending to 0, tan x by x cube. As x tends to 0, what will happen to tan x? It is approaching to 0. And what is happening to x cube? It is also approaching to 0. As x approaches to 0, x cube is close to 0, it is approaching to 0, tan x is approaching to 0. So it is an indeterminate form. Yes, it is an indeterminate form 0 by 0. Another example. Limit x tending to 0, x by integral part of x square. Limit extending to 0, x by integral part of x square. Is this an indeterminate form 0 by 0? Let us see. As x approaches to 0, numerator is x, it is approaching to 0. Denominator, as x approaches to 0, x square is a quantity slightly positive but close to 0, and integral part of that is 0. It is not approaching to 0, but it is 0. So denominator is 0. It is not approaching to 0, it is 0. So this is not an indeterminate form. This is not an indeterminate form. So what we need to be clear here is, when we say x approaches to a, there are two parts of it. First meaning is x is not equal to a. If x is a, I cannot say x is approaching to a. X approaches to a means x is not a, and x is close to a. X is in the neighborhood of a. So denominator is not approaching to 0, it is 0, and that is not an indeterminate form. So in indeterminate form 0 by 0, numerator should approach to 0, denominator should approach to 0, none of them should be 0. Let's look at another limit. Limit extending to 0, integral part of 1 plus x square whole power 1 by x. Limit extending to 0, integral part of 1 plus x square whole power 1 by x. Now, is this an indeterminate form? Power is approaching to infinity. Power is approaching to infinity or minus infinity depending on LHL or RHL. So this is an infinitely large number. But what is the base? Is it approaching to 1 or is it 1? As x approaches to 0, x square is a small positive number. plus 1 is slightly greater than 1. And what will be integral part of it? It is not approaching to 1, it is 1. It is 1. So base is 1 here. So this is not an indeterminate form, as this is not approaching to 1, but it is 1. So is it clear what are indeterminate forms and what are not? Limit extending to a, f of x by g of x is of an indeterminate form 0 by 0 if as x approaches to a, f of x approaches to 0 and g of x approaches to 0. Similarly, this will be of an indeterminate form infinity by infinity if numerator tends to infinity and denominator tends to infinity as x approaches a. And it will be of an indeterminate form 1 power infinity, limit extending to a, f of x power g of x is of an indeterminate form 1 power infinity if f of x approaches to 1 and g of x approaches to infinity. So this is what indeterminate form is all about. Now let us see why are they called indeterminate forms. Why are they called indeterminate forms? Look at small examples. Limit extending to 0, x by x. Numerator is approaching to 0, denominator is approaching to 0. So this is an indeterminate form 0 by 0. And what is the answer? 1. All of you know it, it is 1. Limit extending to 0, x square by x. Numerator is approaching to 0, denominator is also approaching to 0, and x gets cancelled, and what will be the answer? 0. So this is again indeterminate form 0 by 0, but what is the answer? 0. Another example, limit extending to 0, x by x cubed, numerator is approaching to 0, denominator is also approaching to 0. X gets cancelled, you are left with 1 by x square, denominator is a small number, numerator is 1, so what will be the ratio? Infinity, it will be plus infinity. Similar examples, standard limits, limit extending to 0, sine 3x by x. How much will be the answer? 3. Limit extending to 0, 1 minus cos x by x square. Standard question in your textbooks. You can apply L'Hospital rule or power series, or can do it directly using trigonometric manipulations. What will be the answer? 1 by 2. Limit extending to 0, sin x minus tan x by x cube. You can apply L'Hospital rule here, or you can use power series expansions, or you can take sin x common and simplify it. What will be the answer? Minus 1 by 6. So what is common in all these 6 questions is, all of them are indeterminate forms 0 by 0. Indeterminate doesn't mean that you will not have an answer. You cannot determine the limit. It just means that just by knowing the form that it is 0 by 0, you cannot conclude anything about the final answer without knowing what is f of x and what is g of x. Just by knowing that it is 0 by 0 form, you cannot make a conclusion about the final answer. Final answer can be 1, it can be 0, it can be any rational number, irrational number, infinitely large. Whatever it is, you cannot make any conclusion of the final answer just by knowing the form. Such forms are called indeterminate forms. So indeterminate doesn't mean that you cannot determine the limit. Of course, we are there to determine the limit, but just by knowing the form without knowing what f of x is, what g of x is, and how they are related, you will not be able to make any conclusion. That is what indeterminate form is, and that is why it is called indeterminate form. Just by knowing that it is indeterminate form, you cannot conclude anything about the final answer. So let us come back to the original question. Why are these 7 indeterminate forms and why are these not? Now, if numerator is approaching to 1 and denominator is approaching to 0, numerator is a number 1, denominator is a very small number close to 0, then what will be the ratio? It will be a huge number, infinity or minus infinity. So you are able to make some conclusion about the final output. So it is not indeterminate form. Likewise, infinity multiplied by infinity, a very large number multiplied by another large number, what will be the output? Larger, right? So you are able to make some impression about the final output. So again, it is not an indeterminate form. Infinity plus infinity, large number added to another large number, what will be the output? Pretty large. So this is again not an indeterminate form. A very small number, let's say 0.01, when you square it, what will happen? Smaller. Cube it, much smaller. Raised to the power infinitely larger. Very, 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 very small, right? So this is again 10 into 0. So absolutely, this is not an indeterminate form. You are able to conclude about the final output just by knowing the form. So this is again not an indeterminate form. So none of these are indeterminate forms. Only these 7 forms are indeterminate. Why? A small number divided by another small number, I cannot even say whether it is greater than 1 or less than 1 unless I know whether numerator is larger or denominator is larger, right? So unless you know what is f of x and what is g of x, you cannot draw any conclusion. Similarly, a large number divided by another large number, unless you know which one is larger, you cannot even say whether the number is less than 1 or greater than 1. So again, this is an indeterminate form. So these are the only 7 indeterminate forms. Infinity minus infinity, a large number you are subtracting from another large number. Unless you know which of the two is larger, you cannot even say whether the answer is going to be positive or negative. So this is again an indeterminate form. So these are the only 7 indeterminate forms. And in next section, we will be looking where L'Hospital rule fails. So keep commenting in your chat box. Where do you think that L'Hospital rule fails? We know in 0 by 0 form, infinity by infinity form, you can differentiate numerator separately, denominator separately. That is what is your L'Hospital rule. L'Hospital rule, if at all it fails, just tell which example, one example where L'Hospital rule fails. If you like the video, like it, subscribe it, and see you all soon.